David Smith here with another flipped classroom math video. A few tips before we start. Remember that you can speed up or slow down the playback if that helps you follow along. You can also pause the video at any point to catch up with your notes or to try the problems before I explain. Lastly, you can turn on the captions and follow along with my words on the bottom of your screen. Today's topic, quadratic function graphs. So in our progression through quadratics and all the things we've done, now we're going to start graphing them. And I want you to pause for a minute. Anyone know what a graph of a quadratic looks like? Like, consider this one. Here's our simplest quadratic function. It's just simply y equals x squared. They don't get more simple than that. Do you recall, or do you have a guess, or have you seen what one of these graphs look like? If you thought parabola, you're right. So let's see what this one in particular looks like. What I have is a four-step process that helps you make graphs by plotting points on the coordinate plane. So let's get started with that. So your first step, make a table of values. So sometimes I call this a t-chart. I organize these vertically, but the book sometimes organizes them horizontally. Either way is fine. And then x is the value that you get to pick. So what I recommend, until you get more familiar with these things and you understand kind of what works best for your x, just start by using -2, -1, 0, 1, and 2. For this parabola, for y equals x squared, these 5 x values will capture what's happening with that parabola perfectly. Okay, so I'm going to do all the math out loud because it's super simple. If x is -2, we plug -2 in here and we square it, we get +4, so that's going to be y. If x is -1, again we square it according to our function. -1 times -1 is +1, so that just goes to 1. 0 squared is 0. 1 squared is 1, and 2 squared is 4. Now before we move on and plot these points on the coordinate plane over there, take a look and see what you might notice. There's something interesting going on here. Check it out. X is going smoothly from -2, getting bigger to -1, going to 0, going up to 1, going up to 2. Nice orderly progression. However, the y value starts at 4, decreases to 1, goes to 0, and then suddenly goes back to 1 and back up to 4. Now every parabola is going to show that in the y column of your t-chart. So if you've picked values here that don't show that turning point where it stops decreasing and starts increasing, then you need more values here so you can capture that crucial moment where it goes from decreasing to increasing or increasing to decreasing. And we'll see some of those a little later. Okay, so now I've got 5 nice points that I can graph. So pay attention to how I draw my coordinate plane and how I scale my axes, because a lot of students just waste time on this. You don't need too much. So the first step is just to draw your axes and label them, x and y. It's best if you put arrows on them. Now let's look at the range of points we have. Our biggest number is 4, okay? And on this side, we're well within 4. We only go to -2 to +2. So I don't need to scale my axes all the way up to 10 or 20 because that's just too much. In fact, here's what I'm going to do. I'm going to call this 5, this -5, that +5, and that -5. And so now I know that all 5 of these points are going to fit inside here because nothing's bigger than 4. Now if I want, I can put my little tick marks for 1, 2, 3, 4, 1, 2, 3, 4, -1, -2, -3, -4, -1, -2, -3, -4. And that helps us do the graph. So that's really all you need for these points to graph them. Okay, so now let's do that. Let's graph them. First point is -2, 4. So -2, 4. Right about there. -1, +1. So -1, +1, right about there. 0, 0, right there. +1, +1, and 2, +4. So there are my points. Now I want to connect them with a nice smooth line, and I can see that this is just going like this. Put arrows on my graph, And that's my parabola. That's the parabola shape. Okay? So I didn't write down the steps that we did. Okay, so let's do that. But we're essentially done. If you had a math problem that said graph this function, y equals x squared, that's your graph. Okay? So step 1, table of values. Step 2, draw and scale axes. That was that first part we did. Step 3 is plot points. So that's when we put these points on our coordinate plane. And then step 4 is sketch the parabola. And we're done. Okay, I want to talk about this particular graph. This is just that same graph we just made for y equals x squared. You want to really understand how this graph works. This is the simplest parabola, so it's the easiest one to understand. Every other parabola is a version of this. So if you understand this one deeply and really well and can graph it and see how things change, then when you get another parabola, another thing to graph, you're going to have a lot to stand on. You're going to be able to do that. So I want to make some points about this. First off, this parabola opens upwards. Okay? And this is what we mean by opening. The open part is pointing up. So this opens up. What do you think it would take to make it open down? Okay? How could I make it open down? The trick would be to put a negative in front of the x squared. So that would take every value you put in for x and make the y negative. You remember when we graphed this, all the y's were positive. They're all above the x-axis. So if you just put a negative in front of the x, it would then open down. So there's two broad families of parabolas, those that open up and those that open down. And trust me, you're going to get some that open down. Okay, second thing to notice. This right here, we talked about it when we plotted points. This is a turning point. And a turning point is where the parabola, in this case, is going from decreasing, it turns, and now it's increasing. So this is a very special point in this function. And so not only do we call it a turning point, what we really like to call it is the vertex. Okay? So in this case, the vertex is at the center of the coordinate plane at the point 0, 0. Okay? So that can move around. Different parabolas will have turning points at different places. Okay? The last thing I want to point out with this graph is that it's symmetrical around the y-axis. And what that means is that every point on this side has a corresponding point on that side. So, and you noticed that when we had our table of values, -2, -1, 0, 1, 2, 4, 1, 0, 1, 4, you can see that 2 and -2 have the same 4. That's -2 for x, +4, +2 for x, +4 for y. So that's what that means. They're symmetrical around the y-axis. The other way to look at that is that you could reflect this side across the y-axis and it would match perfectly with the side that's on the other side. Okay? Okay, so let's graph a more complicated quadratic function. So instead of y equals x squared, now what we have is y equals x squared minus 2x minus 1. So these should be familiar to you, quadratic equations of this type. We've been playing with these in quite a few chapters. So let's do our first step. We're going to make a t-chart. Now I'm going to make it a little bit expanded. You don't have to do this, but I find that sometimes it's really helpful to create the middle section where I can put my function, x squared minus 2x minus 1. So that way, what I'm going to do is have a plug-in step there so I can see more carefully what's happening with the function. So minus 2 for x. Let's do minus 1, 0, 1, and 2. And see what we get on the y side, and we might need to add another point depending on what that is. Okay, so plug-in step. Minus 2 squared minus 2 times minus 2 minus 1. I just plugged in my negative 2 for x and left everything else the same. So minus 2 squared is 4. Minus 2 times minus 2 is also 4. So this is 4 plus 4, that's 8. Minus 1 leaves me with 7. Now we'll do the minus 1 with the plug-in. Minus 1 squared is 1. Negative 2 times negative 1 is positive 2. So this becomes 1 plus 2, which is 3. Minus 1 leaves me with 2. Now 0 is usually a pretty easy one because we have 0 squared minus 2 times 0 minus 1. That's 0. That's 0. So this ends up just being minus 1. Now notice how we're increasing on this side, going from negative 2 to negative 1 to 0. On this side, we're decreasing. We're up at 7, now we're at 2, now we're at negative 1. Interesting. Let's do the plug-in step for 1. Okay. 1 squared is 1. 2, negative 2 times 1 is negative 2. So combining these, I get negative 1 minus 1 more is negative 2. So we're continuing to decrease. Last plug in here, we'll do 2 squared minus 2 times 2 minus 1. What do we get? This is 4 minus 4 minus 1. So this is minus 1. So now we've started to increase. So we've passed the turning point. Notice how this is decrease, 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 but now we went from negative 2 to negative 1, so now we're getting bigger. So we passed the turning point. I'm going to do one more point just because it's going to make our graph a little better. So let's try 3. This becomes 3 squared minus 2 times 3 minus 1. 3 squared is 9. This is minus 6. So 9 minus 6 is 3. Minus 1 is negative 2. Positive 2. So this makes sense. We continue to increase. Okay? So now I have 6 points. This should be enough to make my graph. So this was step 1, T-chart. Step 2 is graph. So what I'm going to do is make and scale my axes. Okay. Now let's take a look at what I've got going on. My biggest number is 7. Okay? On the x side, I'm only going from negative 2 to positive 3, but on the y side, I get all the way up to 7. So what I'm going to do with this graph is I'm going to decide that 10 is my high point. Let's make this a little bigger. That's 10, and this would be minus 10. So everything else is going to fit within there. I could mark the halfway points. This is 5, that's negative 5, and that's negative 5. Okay, and if you want to make tick marks for every individual one, you can, but we can be accurate enough for a sketched graph with what I've got there. Okay? First point, minus 2, 7. So we go minus 2 up 7. That's somewhere right about there. Minus 1, 2. So we go minus 1 up 2. That's right about there. 0, negative 1. So that's 0, negative 1, right about there. 1, negative 2. So now I've gone 1 that way, and I'm at negative 2. So that's probably right about there. Now I go 2, and I'm going back up to negative 1. So I'm 2 over, and I'm back up at negative 1. So check it out. We noticed this in the numbers that we passed a turning point when we went from negative 1 to negative 2, then back to negative 1. And you can see that turning point happening right there in the graph. Let's do this last point. 3, 2. So we're over 3, and we're going to be up 2. So that's like right about there. Now I have enough to draw my parabola. It's going to go like this and cut over like that. Oh. Okay? And that's good enough. I know some of you are perfectionists out there, and you're going to want to have your graph look a lot better than that, and you can do that, especially if you're working on graph paper. You can be pretty precise with graph paper. Okay, let's take a look at one type of problem that you'll see in the exercises. Here it's written out. Does the point 2, -8 lie on the graph of this function? And here's our quadratic function, minus x squared minus 3x plus 2. So let's talk about what this means, because students often get confused about these types of problems. If this point is on this function when it graphs, what that means is that if you put 2 in for x and simplify this out, you should get -8 for y. So that means that the point 2, -8 satisfies this function, okay? Otherwise, if you put 2 in for x and you get a different number than what the function gives you, then that point's not on the function. So it's kind of simple. What we would do is we would plug in -8 for x and see what it spits out for y. So I'm going to go y equals minus 2 squared minus 3 times 2 plus 2. Before we work this further, I want to point out something. Notice how I put the -2 outside of the parentheses. This is just to make sure I do my square first and then put the negative on it. I'm not going to take the 2 and make it -2 and square it. That's not correct. It's not the way to do order of operations. Okay, working right on. Y equals, so 2 squared is 4. Now I put my negative on it. That's -4 minus 3 times 2 is 6 plus 2. And what does that give us? That gives us -8. So it's true that the point, because I put 2 in for x, I crunch the numbers, and it spits out -8. So yes, the point 2, -8, does lie on this function, on the graph of this function. So we can go, yes. Okay, I wanted to give you one to try for yourself, okay? So same function as before, new point. Does this point lie on the graph of this function? So go ahead and pause the video and work those numbers and see if you can determine the answer. Okay, let's see how you did. Y equals, I'm going to do my plug-in step. My minus is out here. Then I have my -3 squared minus 3 times -3 plus 2. Okay, so that's my plug-in step. Let's continue. -3 squared is +9. Then that minus comes in and makes it -9. -3 times -3 is +9. -9 plus 9 plus 2. This is going to give us 2. The 9's obviously cancel out, and we're left with 2. So if you don't see the answer yet, pause the video and see if you can figure out, does that point lie on the function? The answer is, no, it does not. If it did, we should get 4 out when we put -3 in for x. But we got 2 out. So this point does not lie on the graph of that function. Now that you've finished, take a moment to write down any questions so you can bring them to our next class and get some help. You can also watch the video again to improve your understanding. If you enjoyed the video, please click the like button down below, and if you'd like to help me grow my YouTube channel, please click subscribe.